We are done with the explanation of the each unit of the structure of AES, right? We have discussed all of the units, that is the steps which we follow in implementing AES. So now we will be discussing the whole design of AES with each and every step and the sub steps which we follow in in the steps which we call as a round and pre-round and all these steps, right? So we have used in AES we have used four types of transformation for encryption and decryption. So we have used four transformations at encryption side and the inverse of those transformation at the decryption side. So in this standard, the encryption algorithm is referred to as the cipher, as we all know, and the decryption algorithm is called as inverse cipher. Right. So now we will be looking at the design of AES, which will involve each and every step which we follow while implementing AES. Right. So as a whole, we'll be looking at the AES design. So two designs we'll be discussing in this section. One is the original design, which we have discussed in previous 2-3 lectures, and we will also talk about the alternative design which we can adopt to implement AES, right? So that is the whole design of the AES, which shows the ciphering and inverse ciphering, right? So which shows the encryption part as well as the decryption part. So this one is the encryption part and this one is the decryption part. And you can notice that here in encryption part we are using these operations: sub byte, shift row, mix column and add round key and all these. And at the decrypting end we are using these operations which are inverse of these operation which we have used at the encrypting end, right? So this is inverse sub byte, inverse shift row, inverse mix column, and add round key will remain same. Okay, so this structure it tells you the whole story of AES, which we are discussing from previous uh, three classes in one diagram only, right? So this is the part which is telling you about the key expansion using the cipher key of 128 bit. Okay, so originally this key is 128 bit, right? And we can make 4 words out of it. So out of this 128 bit key we will be creating 44 words, right? So here you can see this is W0 and this is W43, right? So 44 words we have created, and at each round we'll be using 4 words out of these, right? Then we have this first round, which is which we call as pre-round. Okay, and in that round we add the round key first of all. Right? Then in round 1 we have the first transformation step, which is sub byte, then shift row, then mixing of columns, and then adding the round key. So this round key, how do we generate it? We have discussed it in detail in the last class. Fine. Then in we will follow this process for all of the rounds. Now since we are talking about 128-bit AES, so that is why we are having here 10 rounds. Okay, and there is one more round which is pre-round, so in total we are having 11 rounds. Sorry, rounds will be 10, but the number of keys we are generating will be plus 1, more than this 10 plus 1, right? So number of keys which we will be using for completing this encryption process will be 11, right? So this is the encryption part. Now this ciphertext. Now one more thing which I told you in the first class, which in which we started discussing AES, that in the last round we do not use this mix column. Okay, so if you people remember that, I told you that we use only 3 operations in the last round. So this mixing is not done in the last round. So that is the way this AES has been designed. Okay, and in the first round we use only key. Fine. Then at the decrypting end, what do? We again perform all of these operations, but these operations are now inverse of the operation which we have performed at the encrypting end. So first of all, the add round key, okay, in which we'll be using these 4 words, which are W42, W43, right? Then again we'll be having this first round, which will be performing this inverse shift row, then inverse subbyte, then it will add the round key. Okay, so and at last we'll be having the this mix column, which is the inverse mix column, right? Then we follow this process, and we will be completing up to round 10. And here as well, in the last round only 3 operations are there, no mix column is there, right? So this is how this process is done. And again over here, this number of round plus 1 keys are generated, and they are used for each and every round. Okay, so this is the original design which we have for AES. Now we can improve this design, or we can change this design using some alternatives. And those alternatives are, first alternative is invertibility of subbyte and shift row combination. So what we do is we perform this subbyte operation and then shift row operation at the encrypting end, right, inside a round. And then at the decrypting end, we perform the subbyte operation first, and then inverse shift row. Sorry, we generally apply this shift row first, and then the subbyte. I will show it to you over here, right? So here you can see the last operation is add round key. Here as well, the first operation is add round key. We before this we are applying the shifting of rows. Then shifting of rows is performed over here. So the process which we follow at the encrypting end, we follow the inverse of that process at the decrypting end. ओके, सो जो ऑपरेशन लास्ट में हुआ है एट द एनक्रिप्टिंग एंड, वो सबसे फर्स्ट में होगा, सबसे पहले होगा एट द डिक्रिप्टिंग एंड. तो जनरल स्ट्रक्चर यही होता है किसी भी सीफर का, राइट? तो यहाँ पे हम ऑल्टरनेट डिजाइन इसको कैसे कर रहे हैं? वी आर परफॉर्मिंग दिस ऑपरेशन which has been performed first in at the encrypting side. We are performing this operation first at the decrypting side as well. जनरली क्या होता है, यहाँ पे पहले इस पे डिक्रिप्टिंग एंड पे पहले शिफ्ट रो ऑपरेट होगा और फिर सब बाइट ऑपरेट, इनवर्स सब बाइट ऑपरेट होगा, राइट? बट व्हाट चेंज वी आर डूइंग इन दिस इज वी आर परफॉर्मिंग द ऑपरेशंस इन द सेम सीक्वेंस एट द डिक्रिप्टिंग एंड एज वेल. ओके, तो पहले सब बाइट है, फिर शिफ्ट रो है, यहाँ पे भी पहले इनवर्स सब बाइट है और फिर इनवर्स शिफ्ट रो है. Okay, so this design also we can opt for implementing AES. So just like these 2 operations, we can also inverse the sequence of other 2 operations as well. So we perform mix column first, then we add the key, and at the decrypting end, what we do, we add the inverse key first, and then we use the inverse mixing, right? But in this alternative design, what we will do, will be performing these operations in the sequence which we have followed for the encrypting end. Okay, so पहले mixing होगी और फिर हम राउंड की को ऐड करेंगे. Fine. So this is how we can go for this alternate design. So this is the design which is implementing or this is the structure which is implementing the alternate design which we have just discussed. So here you can see we have just changed the sequence of these operations which we are performing, right? So यहाँ पे जैसे sub byte we are performing first, then shift rows we are performing first, add round key का जो sequence है that will be same. Okay, so इस यहाँ पे decrypting end पे भी पहले add round key इस पे round key हम add करेंगे, then we'll perform this sub byte and then the shift row. ओके, प्रीवियस वाले में ओरिजिनल डिजाइन में हमने क्या किया था, we used inverse shift row first and then the inverse sub byte. So this process goes on for each and every round, right? So this is the alternate design of AES which we can follow. Now if we change the key expansion algorithm, so instead of using this inverse round key transformation in the reverse cipher at the decrypting side, the key expansion algorithm can be changed to create a different set of round key for the inverse cipher. So यहाँ पे हम लोग क्या करते हैं, हम लोग inverse की generate करते हैं, right, for this for the decryption. तो यहाँ पे we can create a different set of round key for the inverse cipher. वो उसका कोई रिलेशन नहीं होगा उस की से जो हमने encrypting side पे use की है, right? So we can change this key expansion algorithm as well. But these things you must know, this is just for your knowledge that the structure of AES can be changed in any way. Okay, but you need to understand the basic structure of AES compulsorily, right? Now these are some examples which shows you which show you the process of implementing these rounds and transformation steps, transformation operations and all these things. So this is just example. So इसमें भी हमें DES की तरह examples नहीं करने हैं, right? इसका भी वर्किंग जो है दैट इज इम्पोर्टेंट, यू नीड टू अंडरस्टैंड द वर्किंग ऑफ द एल्गोरिदम. इसका कोई भी ऐसा क्वेश्चन नहीं आएगा जिसमें आपको ऐसे सॉल्व करना पड़े कि प्लेन टेक्स्ट दिया है और की दी है और उससे आपको सीफर टेक्स्ट को जनरेट करना है, राइट? सो दीज आर जस्ट एग्जांपल्स जिसमें मैंने प्लेन टेक्स्ट, सीफर की और सीफर टेक्स्ट को शो करके आपको पूरा प्रोसेस दिखाया है. So this is the plain text we have and this is the cipher key and this is the cipher text which is being generated using these two values. Okay, and the steps which are involved are, first we will be implementing this pre-round. Okay, and this is how we'll be representing the plain text in the form of state. Okay, a state of 4 by 4 matrix, right, in which we are having 16 bytes. So this will be the input state and this will be the round key, and after pre-round this will be the output state, right? Then it goes into round 1. Then in round 1 you can see that this output state will be acting as the input state, okay, which we have seen in the structure of AES कि एक स्टेप का जो आउटपुट होगा वो दूसरे स्टेप के लिए इनपुट का काम करेगा. So for this step we'll be expanding the key and will be generating this round key and will be performing all the operations, and this output we will be getting, so which will act as the input for the second round. Fine. So this is how this whole process goes on up to round number 10, and at the end of round number 10 we get the cipher text, right? So this diagram, it shows you the states in a single round. So this is the input state. This is telling you the states in round 7. This is the input state. This is after sub byte operation, then shift row operation, then mixing, and then the adding of round key, right? So this will be the output state, right? This is how this process goes on up to the number of rounds which are permissible for the given AES, okay, which is 10 for AES 128, 12 for 192, and 14 for 256. Now this is an example wherein we have all the entries in the plain text as 0, okay, and this is the cipher key. So we can see that if the plain text is made up of all zeros, then also we can have the cipher text which is very complex, right? So this is the beauty of AES. Now we will see the avalanche effect, wherein if we change any one bit in the plain text, then there should be a very it should affect the bits in the cipher text in a huge number, right? So we can see this from here. This is the plain text 1, this one, right? And this is plain text 2, in which we have changed only one entry, okay? Okay, one bit we have changed. So this is the cipher text 1, which is being generated using plain text 1, and this is cipher text 2, which is being generated using plain text 2. So you can see the change in both of these cipher texts, right? Uh, you can see that it 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 gives you a very good avalanche effect, wherein it creates the confusion and diffusion in a very good way. Fine. Now this shows the effect of using a cipher key which has all the bits as zeros, right? So this thing we discussed in a previous class as well. I told you, if you use a key which is having all zeros, then what happens? Then in pre-round and round 1, all the bits in the key will be 0. Then in the second round, will be seeing a pattern in the key, wherein the first and third word and second and fourth word will be similar, but after the second round this pattern disappears, right? So at the end we get this cipher text. So instead of having all the bits as 0 in the cipher key as well, we are having this cipher text, right? So this is a very good thing about AES. Now now comes the analysis of AES, which is the last part. So the criteria for asking for AES by NIST was based on these three requirements, which were security, implementation, and cost. So this thing we discussed in the initial part of AES as well. So we will be discussing all of these things, whether AES supports these requirements or not. So AES was designed after DES, and most of the known attacks on DES were already tested on AES before making it public. So mm, it handled this brute force attack, the statistical attacks, and differential and linear attacks very well. Okay, so we can say that AES is very secure. Then the implementation part, this AES can be implemented in software, hardware, and firmware. And this implementation can, use those tables which we have discussed in previous classes, and it can also use the Galois fields, which I told you कि दोनों methods होते हैं हमारे पास, हम लोग tables का use करें या Galois field का use करें, so the results will be same. So you can go with any of the implementation as you wish. And this transformation can be either byte oriented or word oriented. So that also depends on the application कि हम किस प्रॉब्लम के लिए इसको यूज कर रहे हैं. So if we are going with the byte oriented transformation, then we need only 8-bit processor, and if we are going for word oriented transformation, then we need 32-bit processor. So that is the implementation part. Then the simplicity and cost. So this algorithm is very simple and it can be implemented using cheap machines, okay, and minimum amount of memory. So all in all, it is a very good algorithm which fulfills all the requirement, and it was made public for the use so that everyone can use it. So these all are this is the analysis of AES.